Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the production, properties, and uses of silicon. In our last lesson, we learned about the manufacturing processes of zinc and chromium. We discussed some of the chemical properties of each of these metals and learned about some of their uses. We learned that zinc is used in batteries. It is used to coat iron, and that it is an important part of a balanced diet. We learned that chromium is used to make nichrome wire, stainless steel, and it is used to electroplate other metals. In today's lesson, we are going to describe the production of silicon. We will explain the chemical properties of silicon, and we will describe some of its uses. Students, you might be surprised to learn that silicon is the second most abundant element in the Earth's crust. Silicon rarely occurs as a free element in nature, and it is most commonly found as silica and silicate compounds. These compounds contain silicate ions. For example, quartz is a pure crystalline form of silica, and flint is a hard, non-crystalline form. In order to extract silicon from these compounds, the silica must first be heated with coke to about 3,000 degrees Celsius. This is done in an electric furnace. The molten silicon is removed from the bottom of the furnace and cooled. This process produces a shiny blue-gray solid. The electronics industry requires high-purity silicon. In order to get this grade of silicon, additional steps are needed in the manufacturing process. First, impure silicon is reacted with chlorine. This changes the silicon into liquid silicon tetrachloride, which is then carefully purified by distillation. The purified silicon tetrachloride is reduced to silicon using magnesium. The magnesium chloride is washed away with water, and then the silicon is remelted and made into bars. A final purification is done using zone refining. Students, you will be presented with a series of statements that have missing words. Please fill in the blanks with the most appropriate words to complete the statements.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us go through the statements together and fill in the blanks. Silicon is the second most abundant element in the Earth's crust. Quartz is a pure crystalline form of silica. The electronics industry requires high purity silicon. When impure silicon reacts with chlorine, the silicon is changed into liquid silicon tetrachloride. A final purification of silicon is done using zone refining. If you filled in the blanks correctly, great work. Let us discuss some of the chemical properties of silicon. Silica resists all acids except for hydrofluoric acid. When silica reacts with hydrofluoric acid, silicon tetrafluoride and water are produced. This chemical reaction is used in the art of glass etching. Silica dissolves slowly in hot, molten sodium hydroxide, or sodium carbonate. This reaction produces sodium orthosilicate. Silicon and methyl chloride react at 300 degrees Celsius when copper powder is present as a catalyst. The main product of this reaction is dimethyl dichlorosilane. When it reacts with water, it first produces this, and then the reaction continues on to form a polymer. Silicone polymers are non-toxic. They are also quite stable in heat, light, oxygen, and moisture. Students, let us do an activity. Describe how pure silicon can be produced from silica. Please include the chemical equations in your answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I'm sure you had no problem completing this activity as we just covered this material in our lesson. Let us go through the answer together. Impure silicon is first obtained by reducing silica with carbon. Then, the impure silicon is allowed to react with chlorine. Finally, the silicon tetrachloride is reduced by adding magnesium metal. The magnesium chloride is washed away with water, and then the silicon is remelted and made into bars. Zone refining is used as a final purification process. Students, now that we have discussed the manufacturing process of silicon and ultra-pure silicon, can you name some of the uses for silicon and its compounds?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. This might have been a tough activity because silicon is not an element that is often discussed. Silicon is used to construct transistors and microprocessors. This is because it is a semiconductor. Quartz crystals, which are a compound of silicon, are used to control radio frequencies and television transmissions. Lubricants, lipstick, car polish, and many other materials are made using silicone polymers. In today's lesson, we learned about how silicon is produced from silica and silicate compounds. We learned about some of the chemical properties of silicon, such as that silicon polymer can be created when silicon containing compounds like ethane dichlorosilane reacts with water. We learned that there are a lot of uses for silicone polymer, such as cosmetics, lubricants, and polishes. We learned about several other uses for silicon and its compounds as well. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.